Last session we have completed till half part of AHP program, right? Today we will complete remaining verification, and in the next session we will start with the AHB to APB bridge. Okay, so bridge functionality and RTL design. Now we will see how to write the RTL code for that. And if you are interested, I will share you the UVM for bridge also. You can practice. Okay. So in the last session till where we have discussed, I think sequence item, sequencer, all test cases are completed, right? So how many test cases are written here? 3 tests. Basic single transfer sequence, incrementer, wrap. In wrap, 3 type of wrap sequences, and increment, 3 type of increment sequences, right? So I will share you the code today. If you have any doubts, just you need to check the code line to line, then only you can understand properly, and try to complete all like understanding by Sunday. Okay. So coming to the driver logic, did you remember the concept? Can you tell what are the different signals available in AHB protocol? What are the different types of signals out there? What are the different types of signals in AHB?
Control signals and the data transfer signals. In the control signals, we will have to select the slave H size,
H
right?
yeah,
H right,
size, H
H trans.
H trans, H size.
ready,
Okay.
H ready,
Huh?
H ready,
Okay, H ready.
H master lock.
H master lock. What is the difference between H size and H length? Do we have length signal in AHB protocol?
I think so. We have it.
Length. No? Okay, fine. What is the split and retry response? What does it mean? Split and retry.
Like if the slave is not able to respond, okay, it will wait, okay. The slave is not able to respond to the master,
Okay.
it will wait, okay, so that other master can use the bus.
Retry?
Retry again after completing the master, okay. Then again slave will request to the master.
Okay. Sai, can you explain what is Sai Kukunori? Okay. So can you explain what is the difference between split and retry? Shweta, Ashish, Vinita, Gopinath, Venkatesh, Himadri.
Hello, ma'am.
Yeah.
Split indicates the slave cannot complete the transfer immediately. Okay. Because if slave is busy by doing the other transfer, so
Okay.
it can enable that split response. Okay. Retry on the other hand, signal is a temporary the bus remains under the current master control and the transfer will be reattempted. Okay, now bus after Akbar iteration, master will select the slave right. So then slave is okay to communicate with the master. Then we will have the retry signal response.
Okay, okay, fine. Is that correct? Others? Okay, fine. If you forgot the concept, just revise the recordation once again. Okay.
Okay, sure.
Okay, so AHP driver. In AHP sequence, we have generated three different sequences. As I told, single transfer and a wrap sequence and increment sequence. Okay, coming to the driver, through the driver only we are sending the data to the DUT, transaction data to the interface data, right? So created the class AHB driver extending from the UVM driver. Okay, and creating the virtual interface. You already know we need to create the virtual interface. Through that only we can initiate the transfer. And transaction, we need to create the instance for the transaction so that we can access the data or properties of transaction and share to the DUT. Okay, and driver is a component here, so we need to register the component using the macro. Okay, UVM component utils macro. If it is an object, we need to use UVM object utils. Okay, what are the different type of objects and components we have in UVM? What are
Objects
the
are
different types? Hmm.
and um, um, component types are driver, monitor, scoreboard, um,
agent,
uh,
test.
agent, yeah, environment, test. Every the other thing is component only, except sequence and transaction.
Okay, except sequence and transaction, remaining all are components. Okay, so we need to create the we need to create by using the component util. What happens if we don't create these component utils? What happens if we don't use the factory registration? Component utils is nothing but factory registration concept, right?
Not
Yes.
create.
So what happens if we don't use?
The particular component will be not created.
Okay. Anyway, here
We
in system.
already in UVM already the UVM driver is defined, so it will not since we are extending AHP driver, so the UVM driver class will not recognize it.
Okay, fine. So here already we are writing the constructor, right? By using the constructor also we are creating the memory. Then why still we are using the factory registration here?
To make it more reusable and it makes configurable, reusable.
Okay, so basically, whenever we don't write the factory registration, we have some methods, right? Do hook methods or like uh, callback methods are there. Copy, compare, clone, and remaining there are override, set instance override. So all these things will not work. Okay, so the factory will not able to register the class if we don't use the component utils or object utils. Okay, so that factory override is doesn't work. So if it is not working, then what is the disadvantage? Like it doesn't register using the component util, so that we cannot override it using set type override and set instance override. Okay, so one of the best example is like by creating the factory, we can override the class name easily whenever we are connecting multiple components, multiple drivers. Okay, with the whenever we are inheriting multiple drivers with the main class driver, that main class driver we can override or replace the name easily whenever it is registered with the factory. And also in UVM, we need to use the new method, not new method. We need to use the create method. What is the difference between create and new in UVM?
New is a system Verilog type memory constructor, and create is a UVM based constructor, but it is a factory registration registered constructor in UVM.
Okay, okay. So new is nothing but it's just a standard system Verilog constructor and we can instantiate directly. Okay, but it doesn't use the UVM factory. So no override in concept is not possible, and also polymorphism is not flexible by using the new keyword. Okay, so it just hard codes the class type. That's it. It doesn't override the class type. As I told before, whenever we are using multiple drivers where we connecting one driver from AHB, one driver from AXA, one driver from PCIe, these three drivers are inheriting from main top level driver. Okay, so whenever we want to override the subclass with a different type, we cannot override easily by using the new method. By using the create method, whenever we use create method, we can override that name directly. Okay, so that's why create is a factory based instantiation which is recommended for UVM. Okay, so that's why whenever you see here, we use the create method only. In the connect phase and build phase, we create the not in driver, in environment we use the create method. I will show you. Okay, so it just call the factory to create the object, and also it allows or instance override. Overridden is possible. Okay, once overridden is possible means what, we can reusable the components, we can reusable the test bench, and also configurable the test bench. Okay, configuration is nothing but we have in UVM we have a feature like config db, right? What is the use of config db? Where all data we can put in one database. Okay, we can customize the data according to the usage. Okay, what components you want to connect and what components you don't want to connect, whether scoreboard is enable or disable. So all these things are customized by using the configuration database. Okay, so that also possible by using the factory registration concept. Okay, so what is the use of creating, why do we use the create method in UVM? It's mostly we can override the driver with any other class name by using set type override by type or get type override. We have, there are different. Okay, so that is what create method. Clear everyone? So for components, we need to create the UVM component utils. AHB driver is the name of the class name. So need to pass the AHB driver into the class name, and function new constructor same as a system Verilog. And in UVM, everything we write in terms of phases. What is the concept of phases? If you don't know the concept of phases, I will share you the recorded session very clearly. I have explained. Okay, you can observe the difference between events in system Verilog and phases in UVM, and what is the use of phases? Why do we need to use the phase in total execution? How the flow of execution, everything explained in detail, so you can check that once. Okay, so here function void build phase, we have 9 type of phases, right? 9 or 11. So first one is a build phase, function void build phase. In build phase, we will just create the components at top level. Okay, like what is a sequencer, driver, monitor, scoreboard. We will just create top level. So except run phase, remaining all our functions only, because in the run phase we write main functionality which takes some time to complete the task. Okay, complete the execution. So it runs at some simulation time, where in task we involve some simulation time or events or any timing constraints we put. But in functions we should not put any times, right? Events or wait statements, anything we should not put in a functions. Okay, so that's why run phase is a time taken. So that's why only run phase we write as a task, remaining all our functions only. Okay, so here function void build phase, UVM phase, super dot build phase we are calling, and config db get. Already we need to set the data in some file in test bench top level test. And then we need to call the get method here, config db. If you forget the syntax, just go through the syntax here, how we are using the config db and get method. Okay, next UVM info statements. I already told, right? In UVM, one of the best advantages reporting mechanism. In system Verilog, we don't have the reporting mechanism. Directly, we write the dollar display, dollar monitor, dollar strobe, and dollar write, these statements. Okay, whenever we want to debug, that time also we need to write the multiple dollar display statements. It is very difficult to debug the data. Why? Because if there are most of the dollar statements, so at the debug point of view, those are helpful. But once debug is completed, once test is getting correctly, all dollars display statements are not required, right? Because whenever we get the error, suppose at this 13th line getting some error. Okay, so whenever we want to debug this 13th line error, first we will check why it is getting the error and which line it is getting the error. So we need to write the display statement before 13th line and after 13th line, so that we will check the actual error, how where the functionality is failing. Okay, like that, in debugging process, we will add multiple number of dollar display statements. Okay, but after debugging, once we get the error successfully completed, it is difficult to remove all those display statements. We need to disable or we need to comment all the display statements, right? But instead of using that, in UVM we have direct info statements, direct errors it will generate, directly warnings it will be generate. Okay, so just we need to write the macros like this. Okay, and you already know what is meant by UVM low, UVM high, UVM medium. These are nothing but verbosity levels, just to set the priority in the sense which statement should print first and which statement should print next. Okay, just to indicate that the verbosity levels we are using here. Okay, so like that we write the build phase. Build phase is the starting phase in UVM. Okay, there are nearly we have build phase, connect phase, run phase, end of elaboration, start of simulation, extract phase, and report phase, final phase. Like this, we have different types of phases. Okay, but in this phase, mostly we use build, connect, run, end of elaboration, start of simulation, and report phase is to get the extract the data from the monitor, and also we can extract the data in the coverage from the coverage. Okay, so report phase, extract phase mostly we use, but even if we don't use also no problem. Okay, first four phases are important till run phase, end of elaboration. Okay, so next, run phase. Virtual, why do we use? Means mostly virtual is nothing but to override the data. We use the virtual word, right? So that's why virtual task, run phase, UVM phase. Just we are just passing the main top level name, and super dot run phase, because everything is inbuilt in the parent class, right? What is the parent class here? Main library, which is using the library by default library. So that is the parent class. So everything is there in the default library, right? We need to access from the parent class only. So that's why every time we need to call the super dot run phase. Even here also build phase, super dot build phase. Even for here also we need to, even for classes also we need to call the super dot class name, like that. Okay, because by default everything is functionality is available in that. We are not writing any extra functionality here for test bench creation. We are just writing our requirement. Whatever the requirement is there, we are just getting the data and passing the data to the DUT. Other than that, we are not implementing any functionality of the test bench architecture here. Okay, so UVM info statement, next one, just to print the run phase has started. Next, forever, if reset is high, all the variables going to the reset state. Okay, so reset is done here, and h trans is equal to 0, and wait until h reset is high. Once h reset is high, we don't reset the data, right? That's why. Next, at the rate of this dot dot vi of master clocking block with respect to the virtual interface clocking block. Sequence item port dot get next item of request. Nothing but here we need to use get next item. Okay, in the sequence, in body, in task body, we need to create the transaction first, and then we need to send the transaction data start item, then request dot randomize, request the data, and then finish item request, and start item and finish item. These are the transaction flow statements at a sequence side. And driver side, just create the request and get next item and sequence item port item done. These are the three statements, four statements we need to write in the driver. This is what fixed transaction flow. Okay, so next, end task drive, task drive method, drive address, drive data. Okay, those methods we are writing here. Task drive address, what we are doing in drive address, I is equal to 0 to address length I plus plus this dot h address is equal to h address of I. Okay, transaction data sending to the DUT data through the virtual interface. Okay, so this dot DUT VIF. Why we use this here? Negate this dot DUT dot log. Okay, AHB driver extends UVM driver. Virtual AHBIF DUT VIF. this dot VIF dot HDDR. Actually, we need to put DUT dot clocking block dot mod port dot H address. That is what actual path. But without accessing the clocking block and mod port directly, we are using this dot. Okay, we can do like that also. And if request busy state is greater than 0, if I is equal to J, then H trans is equal to 0, 1. Okay, what is meant by 0, 1? What is the transaction? Ideal or non-sequence or sequence or busy? H trans is equal to 0, 0. And finally, this dot DOT VIF H write data is equal to H data, assigning the request H data to the H write data. Okay. So this is what the driver. Here not required. Okay. Next, monitor. Monitor is same as a driver. Okay, just in driver we are getting the data by using get next item from the sequence. In the monitor, we get the data from the DUT and send to the scoreboard. Okay, so here class AHB monitor extending from the UVM monitor, because UVM monitor is a default library. We need to extend from that, right? It's a parent class. Okay, so class AHB monitor, and we need to create the component using component utils, and int count is equal to 0, and UVM analysis port hash AHB transaction analysis port. Can you tell me about analysis port? What is the use of analysis port and how do we connect? Do we use any get method and put method for analysis port?
Analysis port is used to connect monitor with scoreboard.
Oh, okay. One to many connections or nothing but analysis port, right? So
Ma'am, what is analysis implementation port?
analysis implementation side, for analysis port, we don't have the implementation and export, right? We just have the write method. We directly write the data into the scoreboard and coverage. It's a one directional, unidirectional, not bidirectional. By using write method, we directly put the data into the scoreboard and coverage collector, whatever the blocks you are connecting to the monitor. We can connect the scoreboard or coverage collector. If you are using the RAL model, we can connect the predictor sequences like that.
Okay, ma'am.
Okay, so UVM component utils, UVM analysis port, parameterized analysis port, so hash AHP transaction and the name of the instance name, trans receiver, and creating the virtual interface, because through virtual interface only we can access the data, and creating the class constructor here, function you already know we need to pass the name and the UVM component parent. If it is a system Verilog, we connect, we pass the arguments, like for generator, we pass only mailbox, for driver, we pass mailbox and virtual interface, right? Even for monitor also same. For scoreboard also, we will connect only mailbox. Like that, here also same constructor. And function void build phase. In monitor also same, we need to create the build phase. In that we need to get the configuration database, and in the run phase we run the main task, like a super dot run phase forever begin AHP transaction trans is equal to new. trans.h address is equal to new of 1. Trans.h data equal to new of 1. Like just assigning, we have to create below data types as these are dynamic array and we have to give size before using it. Okay. We are giving the size is equal to 1 and we will always take one address and corresponding data in one packet. Just assigning some size for address, data and transaction just to run in the monitor. And next POSH this dot DUT IPIF clock. Actually, we will put that DUT VIF dot clocking block modcode dot clocking block dot clock. But here directly we use this keyword. We can use like that also. Next fork join. Fork join means both the address and data task we are running parallelly. So use the fork join. So this is what address task. And in address task, what we are doing, see here, this dot DUTVIF H write data assigning to the transaction write. In the monitor, we do the same, right? Interface data should be assigned to the transaction data. And same way, H size also. H size should be assigned to the transaction H size. And H address should be assigned here. And H burst, H trans, like that. Okay. Next, for data also
One
same.
doubt.
Yeah, tell me.
In monitor, we use this to transfer data from DUT via interface to monitor. We use blocking statements, but in the driver,
Blocking.
we use non-blocking. I mean, I have this confusion earlier also. Yeah, may I know this, like why it is so?
Here we use the blocking. Okay. In driver we have used non-blocking.
I think, I mean, in other drivers I've seen. Yes, in drivers we see non-blocking.
Hello. Yeah, tell. So your here where is driver? In driver we used a non-blocking assignment here and here and here also. In monitor we don't use the non-blocking. Why? Because in driver mostly how it is working, it should meet until the signals are fully assigned, right? So before advancing to the next transaction, it should have updating the value before the clock edge. Okay, so that's why we need to use the non-blocking as non-blocking assignment in the driver. Okay, non-blocking assignment only if you are reading the DOT output signals. Okay, just to avoid the race conditions. Monitor means anyway we use the blocking assignment for monitor. Interface to transaction to interface, interface to transaction. Suppose in driver is a bidirectional. Okay. We send the data from driver to DUT and also DUT to driver. Okay. Monitor means what? Only DUT to monitor. That means interface to transaction. Okay. Whenever we are using interface to transaction, we need to use the non-blocking assignment. Even for driver also, whenever you are using interface to transaction, there we need to use the non-blocking assignment. And whenever we are using transaction to interface, here request is a transaction and left hand side is the interface. Whenever we are using transaction to interface, transaction to interface means it's non-blocking. Interface to transaction is blocking. Okay. Even in driver, if we are connecting transaction to interface, then we need to use the blocking only, just to avoid the race condition, because where it is driving the signals one by one, that's fine. So monitor, same as driver. And coming to the scoreboard, in scoreboard, create the class AHB scoreboard extending from the UVM scoreboard, component utils, AHB scoreboard, and analysis port. So in monitor, we have written the analysis port, right? So the same analysis port, we need to write the implementation in a scoreboard and a coverage, UVM analysis implementation. Okay, AHB transaction, comma, AHB scoreboard. So in the monitor, if you observe how we kept the data into the monitor, mailbox or TLM port, see here, 81 line by using the write method. Okay. So by using the write method, we kept the data into the transaction class. In the same way, scoreboard. In scoreboard also, just create the UVM analysis port and HB transaction memory and function constructor, and in the run phase, for queue size is nothing but we are comparing the data here, right? We need to write the logic. For that purpose, we need to create the memory here. Okay, so receive data, one by one data we are receiving from the queue, because entire mailbox, whatever the TLM port data is there, we are keeping into the queue and getting one by one data by using the queue friend. Okay, pop friend. So if received data h write is equal to 0 and memory of received data dot h address of 0 is equal to h received data of 0. Okay, so h address of 0 and h data of 0, if both are equal, then it should print UVM info statement should print read operation data is matching. So the data is expected. Okay. If it is not equal, h address and h data is not equal, then error. Actually, here instead of writing h address and h data, we can write h write data is equal to h read data, right? Whenever h write data is equal to h read data, so expected value. If h write data is not equal to h read data, unexpected value. Okay, error. So like that also we can compare read data to write data, address to address also we can compare. Okay, if you are using both same addresses. Next, if receive data dot write h write is equal to 0, memo of receive data dot h address of 0 is equal to h. Okay, fine. That is second condition. And write method, function write method, and q dot push back of received data, just again sending the data to the queue. Okay, so this is how we can write the scoreboard. Not only like this, we can write in different ways also. Whatever the way you already know, just try. Okay, just comparison logic and how we create the memory for the scoreboard. Next, AHP pipeline driver. Okay, pipeline driver in the sense the number of sequences, whatever the task are there, all we are connecting. See here, semaphore concept is used. You already know, right? Semaphore concept. If there are multiple number of tasks, which task should do first, based on the priority wise, based on the key. In a pipeline, we log the pipeline for one transaction first and then second. So based on the key, if any key, that means if any task get the key, the task will do first and return back the key, and second task will access the key and do the function. Okay. Same way here we are using the semaphore concept. That's what we are calling as a pipeline driver. And in the run phase, to two type of transfers are there. Do pipeline transfer 1 and do pipeline transfer 2. Okay, so just see task automatic, what is there in the pipeline. Pipeline log get sequence item port get request accepted TR and just writing the pipeline and sending the transaction data to the interface. And second pipeline, see here, pipeline lockup put. Already here got the pipeline lock of get. All the keys are getting, not only one key. That means if we don't write any key size here, it means all the keys are getting. Okay, if you write one, that means one key is getting. At the time of instantiation, at the time of creation only, we created only one key. So one after another can do the process. So here it is getting the key first and then putting the key back here, and then second transaction will get the key and do the task and put the key back. Okay, so this is how pipeline driver will work. So same as semaphore concept. Okay, just go through that. And next, any doubts still here? Any doubts? Line to line, you need to check clearly, then only you will understand the concept. Even if I explain line to line, it will be boring for you. You need to
Ma'am, please,
try it
ma'am,
from
please
this.
explain the theory.
Huh?
Ma'am, please explain the theory.
Theory?
Theory. Yes.
What is your name?
APB. Ma'am, Karthik.
Theory already explained, right? What
Okay.
theory?
Like why bridge is needed?
Huh?
Why bridge is needed?
Why this is needed? Which one?
Ma'am, which way are designing APB to AHB bridge?
Okay, what I am explaining now. What I am explaining now.
Ma'am, the coding part.
What coding? For what
Designing
design?
and verification. AHB to APB bridge.
Did I explain the specification for AHP to ABB? Did I explain the specification for AHP to ABB theory part? Yes or no? Hello,
Yes.
Karthik.
Yes, ma'am.
Did I explain the theory for AHP to APB bridge?
Yes, explain.
When?
Ma'am, just I want once more.
Without explaining theory, how can I explain the code for bridge? I'm still explaining AHP only. According to your schedule, AHP is only 2 sessions, but this is 4th session I am taking to explain clearly.
Okay, okay.
See, it is AHP bridge, AHP design. I already explained, right, all these concept, bus transfers, different types of bus transfers. In say this is a single transfer and bus transfer with increment 4-bit and increment 8-bit, increment 16-bit, and wrap address. Entire design. Still design I have explained, not last session, before that session I have explained design, and half UVM I explained in the last. Now today remaining UVM test bench I am explaining. Bridge not yet started. Bridge will be starting this weekend, Saturday and Sunday. Mostly Saturday only we will complete the bridge, and from Sunday we will start AXI protocol.
Okay, ma'am.
Okay.
Okay.
still we are just learning AHB only. AHB. Just yesterday session, before session, I completed sequence, sequencer, transaction class, interface class. Today I'm explaining driver, monitor, scoreboard, pipeline driver, environment, test bench.sv, and coverage assertions for AHB. That's it for today. Okay.
Okay, ma'am.
So so this is what AHP pipeline driver. Even if you don't write the pipeline, also fine, no problem. And coming to the environment, you already know environment is a top level of all these four components, right? So class before environment top level is agent. Why? Because in agent only we will put the sequencer, driver, and the monitor. Okay. So these three signals, three components will be called from the agent. Agent is the top level. So class AHB agent extending from the UVM agent, AHB sequencer, just creating the instances for sequencer, driver, and monitor. Okay, and creating the class constructor, and AHB agent is also a component, right? So UVM component util and component util ends. In the middle, what is this? Sequencer, driver, monitor. These three are objects to the agents, low level low level blocks. So UVM all on. UVM all on means what? Whatever the methods, properties are there, everything are active. Okay, so if you want to copy, compare, clone, everything you can do. If you don't want to use any of the method, you just you put like a UVM all on, and next plus no compare, no copy, no clone, like that if you want to avoid any of the method. Okay, next bill phase. In the bill phase, what we need to do? We need to create the lower level components. So sequencer, driver, monitor. Is it active agent or passive agent? Is it active agent or passive agent?
Active.
Active agent. Active agent means it will connect sequencer, driver, monitor, where it drives the data and also monitor the data. But passive agent means whenever we don't need to drive the data to the DUT but want to monitor the data, then we use the passive agent, where only monitor will connect. Okay. So function void build phase, superdot build phase, UVM info, sequencer, driver, monitor need to be created, and function. Next function void connect phase, UVM phase. In the connect phase, we need to connect the sequencer to driver and monitor to the remaining components using analysis code. Remaining all components we will put in a test or environment. So according to that, we need to connect. But as of now, in agent, we connect the driver and the sequencer. So this is what the TLM port to connect the data. So driver dot sequence item port dot connect method. By using connect method, one side is import, one side is a export, the implementation port and a target. Okay. So you need to understand the concepts first of all. Which one should use, the put method, get method. So which side, whether producer should be a initiator or target, or consumer should be initiator or target. If you revise these concepts, you will get understand how we connected here. Okay. So driver dot sequence item code dot connect sequence dot sequence item export. Next UVM info statement. That is what the agent. Agent we write. After agent and sequence should be connected in the test. Sequence okay, not sequencer. Agent and scoreboard should be connected in the environment, right? Because in the agent we have sequencer, driver, and monitor. So these sequencer, driver, monitor, which is there in agent, so we need to connect that agent plus scoreboard in environment. Okay. In the tester, we have the sequence. Sequence will be
Sequence.
run from the tester. So if you remember the top level test bench, so if you see the UVM top level test bench here, the sequencer, driver, monitor is sitting in the agent. Okay. Scoreboard and agent will sit in the environment. Okay. So outside the environment will have the sequence which is there in the test. Okay. Sequence will come from the test. If you observe this test, this architecture, sequence will sit in the test. Okay. So sequence to sequencer we connect, sequencer to driver, driver to DUT, DUT to monitor, like that. Okay, so this sequence we need to call in the test. Same here also. Come to the environment. So in environment we create the agent, scoreboard, sequencer, and subscriber is nothing but a monitor, and creating the virtual interface, and creating the function constructor and component utils and build phase. Build phase is nothing but create the agent, create the virtual sequencer. Because why we are using the virtual sequencer here? Because we have number of sequences, right? Number of sequences are connected to the virtual sequence and virtual sequencer. That's why we create the virtual sequencer. Yesterday I have shown you how to create the virtual sequencer. See here how virtual sequencer and the components are connected, all the sequence components. Okay, so that is how we connect. So in the environment, so virtual sequencers, scoreboard, and subscriber, nothing but monitor. So if UVM config DB get method, we need to write, and in the connect phase, we need to connect the monitor to the scoreboard and monitor to the subscriber. Subscriber is a coverage. Okay, okay. Subscriber is a coverage here. Fine. So monitor to the scoreboard, monitor to the coverage, one to many. Okay. So virtual sequencer dot sequencer is equal to agent dot sequencer, assigning to the V sequencer. So that is how we connect the top level environment. Any doubts still here?
Please once revise the concept of virtual sequence and sequencer. How it's connect, please. So, ma'am, I forgot the concept.
You forgot the concept, or here whatever I explained, did you forget
No,
that?
ma'am. No, ma'am, you explained it well, but I forgot that.
See, virtual interface, virtual sequencer concept is nothing but suppose there is a Ahb protocol and APB protocol and AXI protocol. Okay. In Ahb protocol, we have one sequence, and here also we have one sequence, and here also we have one sequence. Okay.
Okay.
These three protocols we are connecting to the driver, one common driver. Okay. So every time we need to send the data from AHP to driver and APP to driver, and here like that we need to send individually everyone. So without doing that, we are connecting all the sequences to the one virtual sequence. Okay. So by using this virtual sequence, we will connect to the virtual sequencer, and virtual sequencer will be connected to the driver here. Okay. So no need to connect to all the physical sequences directly to the driver for these many times. Okay. In our example, we don't have AHB, APP, AXI, but we have created three test cases. One is for single transfer, one is for increment, one is for wrapper. Three different sequences we have created. Okay. Normally, if we connect to the sequence to the driver, how we will connect through the sequencer we are connecting? We will consider this as a one test, and we will connect this test to the driver. However, we did now through the request command, request get next item, like that we need to connect, and the TLM port also we will connect. But we are taking the three test cases which is inheriting from the main top class. So every time we need to connect to the driver individually. One is from sequence test 1, second one test 2, second third one test 3. All three test cases individually we need to connect. Okay, but it's a physically it's a long process. Okay, so for that purpose, what we are doing, all we are connecting to the one virtual sequence. And anyway, virtual sequence is connected means we need to create the virtual sequencer also. Through that virtual sequencer, we are connecting to the driver directly. Okay, we are just connections are happening only to the virtual sequence and sequencer here. We are not making any connections. We are not creating anything for the driver. Okay, so here you may understand now what is the difference. It is easy to connect the virtual interface. Suppose you are running the 100 test cases. 100 test cases individually, you cannot drive each test to the driver separately, right? 100 test cases we will connect to one virtual sequencer. Through that virtual sequence and sequencer, we will drive to the driver, connect to the driver.
Okay, ma'am.
Did you
Clear.
understood now?
Yes, ma'am. Clear.
Okay, fine.
Ma'am, please show the code now. Now I will understand well.
Okay, wait. So sequence, here sequence, in the sequence, first test bench is AHP single trans sequence. This is one test case. So here we are doing the randomization and generating the values and sending to the DUT here. Okay, and second test, AHP increment sequence. Here also we are doing the randomization and connecting to the drivers, just sending to the driver through the request command. And third sequence, AHP wrap sequence. Okay, so for these three sequences, we need to create the different sequencers separately. Sequencer 1, sequencer 2, sequencer 3. Okay, so without doing that, here we are creating the temporary class AHP wrap sequence, extending from AHP wrap sequence. And here virtual sequencers, see here, virtual all sequencer. So AHP single trans sequence created the instance, and AHP wrap sequence created the instance. AHP increment sequence created the instance. I explained the P sequencer also in the last session. Why do we use the P sequencer and N sequencer? So by using the UVM declare P sequencer, we created the virtual sequencer. Now by using this virtual sequencer, we are going to connect with the DUT. Did you got the point now?
Yes, ma'am.
That's why here we use the pipeline driver also. Pipeline driver means directly we are getting the transaction data from the DU sequencer without creating separately. Okay, so that is what virtual sequence and sequencer. And agent completed, environment completed. Next, test. In the test, we call the sequence. Where is the test? Test. In test, we call the environment and also sequence. So here, virtual interface, UVM factory, and component utils, constructor, build phase, config DB, and end of elaboration. End of elaboration phase is nothing but where we generate in terms of structured path of execution. End of elaboration. If any final changes are there, we do the changes in the end of elaboration and it just print in a topology, which is a reporting mechanism methods. UVM top.print topology. In that table manner, it will be printed. Okay. So class Ahb increment tester, that is one tester, wrap tester, second test bench, third tester, single tester. So phase drop objection. I think you know the phase drop objection, right? Ahb all virtual tests are connected at the one phase. Okay. Just check this. Do you know phase drop objection, phase and rise objection? If you don't know, go to the concept, UVM concept and revise and go through here. Okay, all the test cases are there in the test.sv. And next, testbench.sv. Anyway, in the testbench top sv, we just import the UVM package and macros and AHP test package, and we will connect the interface and the test here. Okay. And next in AHP protocol here written AHP coverage. So covering H burst low 0 to 2 and mid level 3 to 5 and high 6 to 7 and function void coverage sample. We run the coverage by using the sample method, right? So function void report face, UVM face, super dot report display, add coverage. Just a very simple coverage. If you want to write for address data also, you can write the coverage. Okay. Next, assertion. Assertions are written more. Module assertion separately. Initial begin. Inside the assertion, busy state address. One is for address. If h trans is equal to 1, then what is the dollar stable? That means output should be get 0 or 1. So property busy state for read data and for one cycle, state cycle, and for h burst wrap for h burst wrap. You need to understand clearly, everyone. H burst is equal to 2 and dot trans is equal to 2, h study is equal to 1. So what are the conditions? We already written the waveforms, right? You need to compare with the waveforms. Then what is the value of H trans? You need to draw and understand each scenario. Okay. Wrap 8, wrap 4, and H burst. Okay. Here also, you need to draw the waveform and understand clearly. That is what about AHP protocol. Once practice, if you practice and if you have any doubts, I can explain clearly. Sure. Whenever I'm sending the code directly, students will make lot of changes here itself and I will get the errors. Every time I need to do correct the error, they will change. 465. Agent, no errors, all info statements 150. See, in UVM we will get like this report, but in system Verilog we don't get like this. Okay, in UVM we will get 150 info statements, warnings or zero errors or zero fatal errors or zero, like that. And every value will print here. If you observe here, every value, whatever the test cases we write, it will start from here, factory configuration, note instance or type overrides or registered with this factory. AHP agent, AHP all test, virtual test, all just to check here all the data and how the top flow topology, how it is printing. UVM test top and what is the type. In the test top we have environment. In environment we have agent. Within agent we have driver, monitor, sequencer. In driver we have response port, sequence item port. In monitor we have this trans sequencer port. We have a driver monitor, like that. Every data you will get here in sequencer. What statements run phase is started here. Okay, reset phase is completed, build phase and run phase is started here. Once run phase is started, inside the body of virtual sequence, what are the values are printing in the scoreboard, what data. Write operation data is 84 for address CC. So data is matching with the receiving 84 and expected data is 84 for address CC. So data is matching, like that. All, see, there are a lot of data. Okay, every line to line you can check and observe how it is working. And if you click on run.do file, it will extract the coverage also. And waveform also we have what are the H burst signals and what are the size, H trans, H write data, H write, H read data. Just check here, H read data. You can take in decimal or hexadecimal also fine. 6 H write data. Read data 75 60 40 24 08 000 65. Okay, here address 3. Address 3, what addresses we have? Check a write address and read address. Address write address, which address 027B 27C 27D and EF. Inputs are 65 65 we got. 3E didn't, 3 also we got at 376. DF also we got. 73 also got. 60 also we got here. 60 didn't got. 1A also no. 0110. According to the address we will get. Okay, if you have any confusion here, you can see here the all statements. Coverage is not generating. What is the error? Launch. We will change that. Coverage. Did we return the run.do file here? Run.do file is access is called. Okay, but why coverage is not generated? Okay, fine. Just check from your side also. Code wise, it is working perfectly. Okay. Coverage we need to generate, and once check with the Questasim tool also. Okay. If it is time taken process, just observe in the code itself. Okay. So from your side, you need to understand clearly how the each line is working. Then only you will get the clarity overall functionality. Okay, and try to write the test cases. That is very important thing. Take a simple example, very simple adder or just a register whatever, and try to write some program, develop some program. Okay, so that will be the best practice in future also. It will be helpful. Any other doubts? I don't have any doubts. It depends on your inputs and outputs. Suppose actually in real time, whatever the size you consider in the test bench, whatever input size, you need to generate all scenarios. If it is a 32-bit size, 2 power 32 scenarios we need to cover. Okay. If you take 3-bit size, 2 power 3 scenarios, we need to cover all possible scenarios according to the functionality. That is really in industry it will happen where we generate all the coverage for every bit, every scenario. But practice level, we no need to concentrate that much. Okay, just small scenarios, constraints only, right? Test cases or nothing but what different types of constraints we generate. So you can generate small constraints, big constraints, like what specifically you want to verify, which scenarios you want to verify. Draw a table. Suppose in AHB protocol, you want to verify H address as like 0 to 100 addresses only, multiples of 5. So write the constraint for that. And data also you want to generate specific values. So write the constraint for that, and you can divide whole thing in 2 or 3 test cases. Okay.
Okay, ma'am. Like, ma'am, we are generating 2 to the power 3 means 8. We can segment it into 4,
Uh, 2 test
4
cases
test
if you want
cases.
to do 4 bits, 0 to 3, 3 to 7. If you want to take as a 3, you can divide total 8 into the 3. Same in coverage also. Bins you need to divide into 2 bins or 4 bins or total 8 bins also we can generate.
And when we can cross bin also.
Yeah, cross also we can. Actually, we need to do cross only, but normal also we can do.
Okay, ma'am.
Cross is easy compared to normal one. Directly we will get the values.
Yes. 2025 per batch internship. Okay.
Thank you, Ahb.
Thank you, ma'am.